Now let us focus our attention on the continuous rotation. A continuous rotation about a point, which is called the center of rotation, is a continuous motion of points for which the following holds. All points move in a circular fashion around the center of rotation. I'm not going to go into greater details of what that means. I'm referring to your intuition, what it means for circular rotation, for circular motion. And the distance between each rotated point and the center of rotation does not change. So the distance between this point and the center of rotation does not change. So if a point A was rotated into the point B, then the distance between O and A must be the same as the distance between O and B. These two distances must coincide. That's what the second statement means. The distance between each pair of rotated points is preserved. So if I take one pair of points, A and B, and I rotate both of them into A prime and B prime, then the distance between these 2 points, this arc, this segment here, must be exactly of the same length as that segment. So the position of a point under continuous rotation is assumed to be a function of time. So in fact, for this definition to make perfect sense, we also need to parameterize time. We need to introduce a variable for time, and that gets a little bit technical. So we're not going to do that. We're going to stop here with our definition. The trajectory of a point under continuous rotation is an arc of a circle. So a point can traverse a full circle more than once, right? So, right, because when we're having a continuous rotation, as time passes by, a point can revisit places which it used to visit. So, so I'm allowed to do this. I'm allowed to move the point B around. I'm allowed to move it around, and it's allowed to go back to where it originally was. So when we have continuous motion, it is allowed to repeat parts of arcs.